So there's one last thing to talk about today, and that's the area of the triangle. We all know that the area of every triangle is 1/2 base times height. So the same generic oblique triangle ABC from earlier that we dropped the altitude from point C, that altitude is the height. So C must be the base because that's the side that the altitude drops to. So the area of this triangle is 1/2 C times H. But recall that we have expressions for H that we saw earlier. So pause the video, see if you can figure out what is an area formula for any triangle. And we don't want to use H. We only want to use A's and B's and C's. So give it a try. Now that you have paused the video and tried it out yourself, let's give it a try. We're going to use K for whatever reason, I don't know why, is the area. That's 1/2 C times H. But what is H? Well, I don't know. Let's go back and check. Earlier we saw that H was equal to B times the sine of A. So we've got H is B times the sine of A. Okay, but we also have area equals 1/2 C times H, but we had a different value for H. What was that value? Oh yeah, here it is. It's H equals A times sine B. So we also have 1/2 C times A times sine B. So those are two different area formulas for every oblique triangle. The first one, I'll write it in alphabetical order. Instead of CB, I'll say BC, because multiplication is commutative. We can do that. So it's 1/2 BC times sine of A. Also, we've got 1/2 CA, or AC, times the sine of B. And that's two different equations. But I'm wondering if anyone can figure out that third equation, just based on the symmetry. We could have used a different altitude. But we should be able to, based on the symmetry of these formulas, we'll see that there's one more possibility. Don't use sides B and C, don't use sides A and C, but instead use sides A and B. And then for the angle, don't use A, don't use B, but use C. So this works for every single triangle. If you have, I guess you would need a side angle side situation. Like, for example, if you had side B, which is this side right here, and side C, which is this side right here, and you had angle A, and when I say had, I'm saying you know them, and that means if you have two sides and the included angle, that's a side angle side situation. So even though, well, we'll get into side angle side later on with law of cosines. Better not jump ahead of myself. But this is an exceedingly easy formula to use, provided that the two sides you have are the sides that include the angle that you have. And we can tell that that's the case in this problem because they all use a different letter, just like in each of the formulas up there. They all use one A, one B, and one C. So our area, we'll call it K, for whatever reason, is 1/2 the product of the two sides. So B is 21.2 inches and C is 16.5 inches, times the sine of the included angle, in this case sine of 25 degrees. Calculator time, 1/2 times 21.2 times 16.5 times sine of 25 degrees. And I'm not going to say that's equal because we all know that we rounded this. It's going to be approximately equal to 73.9. 73.9, and then after that is a 1, so the 9 would stay a 9. That would be the numerical answer, but if you have units, you should use units. What are the units? Well, you can notice that we've got inches here and we've got inches here. What is inches times inches? It's inches squared, which makes perfect sense because this is an area problem and square units, whether they're square inches or square meters or square miles, that's how you measure area. So Why did I put an equal sign there? I shouldn't have. I should have put inches squared. And that is how you do the area problems in this section.